looking into the various data mining tasks, descriptive, predictive, everything on them. So this one thing I want to sort of look into this. Okay, this is your marks. It's nothing new. This is your marks. Probably everyone knows this. Okay, this is your marks. I want to sort of look into few of the what you call visualization tools in very simple things, whatever you see when it comes to your Excel itself. Okay. This is a marks. Just go here. This is a marks. Whatever you see is your internal marks. The internal marks of your 5th semester. Okay, what is the average you get? The average you get is around 35 out of 50. 35 out of 50, which basically I'm talking about the entire class average. It comes to around 70%. Okay, 35 out of 50 is 70%. No, 35 out of 40, right? So yeah, it's not. It's even more than that. 35 out of 40. It's 1 second. I'll just calculate here itself. Okay, so I'll just show few of the visualizations that are possible even with your Excels. Okay, 35 out of your 40. So what is the percentage you get? Okay, you get 87.5%. That too in IS of an entire class. Okay, that is your percentage. And then this is a marks you guys have scored in your VTU exam. That is the result which you got tested. What is the average you get? You get an average of around 30. Okay, out of 30. So what is this marks? Out of 60. So that's close to around 50%. Okay, that's close to around 50%. Now your internal marks was, the class average was 87.5. The external marks, the class average is 50%. So when you put all those two things together, 40 and 60 together, out of 100, what you get is close to an average of 66. This is what I'm talking about, the class average. The class average of your entire class in externals, including your internals and externals, out of 100 is coming up to around 66, which you can clearly see here. Okay, which is somewhat okay. Probably it should have been more than 70, would have been a nice thing. But again, there are few people who are outliers, because of which it has come down. Okay, come down very, very drastically. 66 is not good. Should have been more than 70. Okay, this is for a subject which has relatively better results. I don't know what will happen if you look into a subject like a Python or an ATC. Okay, so yeah, fine. That's not our thing. Okay, it's all your problems now. You have to keep on working. Otherwise, it's going to be a tough ask. Okay, now just taking your the external marks. If I take our external marks and I sort of plot a graph to it. Okay, a very easier one would be to plot a graph which basically looks like this. Okay, what is this one? This one is a scattered graph. Okay, it's a scattered, what do you call, using bubbles and all. I've written a graph like this. I've plotted a graph based on your marks. You just take out this. Okay. So let's plot out this graph again. So I'm using a scattered graph like this. Hopefully now you will be able to see this. Now look into this. Okay, what is the thing that you can see and what is the thing that you cannot see? And this is the graph I'm talking about. Okay, now if I do this, if I take this into perspective, the graph which you are seeing now is the marks related to your the ME subject last semester. Okay, ME subject last semester, you can see this graph. Okay, majority of it is basically coming like this. This is for your external marks. Okay, this is for your external marks. Now what is a thing that is very much relevant here? Okay, relevant here, or if you take, I'm talking about only external marks what you got, which is converted to 60. What is the thing that you can easily make out from this? The thing that you can easily make out from this is majority of the people are basically coming in clusters related to year. Okay, you got this. These are the entire clusters what you see here. The clusters which you see right here, and of course the clusters which you can see here. Some of them are outliers. Okay, now you can see very clearly that some majority of it is coming in between. You can see right here, this is 20, which is the passing marks is 21. Between this and your, of course, your 50, which is out of 60. Few people have got more than 50. Okay, out of 60 I'm talking about out of 60. And there are few people who are, see this, these are called as outliers. 1, 2, 3, and 4. And you can see the marks also. I can easily show the marks. You can even make out the marks from it. Okay, it is, series 1.34. Okay, roll number 34. Person who knows that. Okay, then again here, what is it? Roll number is 50. Okay, sorry, 26. Now these are people who are outliers. You can see very clearly that they have scored very less marks. Okay, very less marks, but majority of them, basically come between what is known as 20 and 40. Okay, 20 and 40 between for your 60 marks. Or if I take this entire thing for the marks that you see right here, okay, for figuring out something like, if I take a marks even including your entire for 100 marks, internals and externals, and if I go for a very good graph line like this, I like this graph. Okay, it's a graph that basically showcases everything of where we are going down. Okay, this is called as a line graph. Okay, how lines vary. So if I go for this, now you just look into this. Okay, how this thing is varying. It is varying in a way that you can understand from here. Is, see, this all these things are simple visualization tool. Okay, simplest of visualization tool, which probably everyone will be knowing because it comes with a in default by, inbuilt by default in Excel itself. Like this, they will be having majority of the tools which are sort of used for their own company's perspective. Okay, in data mining or in data applications on that, which people will be able to do and figuring out where the data is going through on that. Okay, see this is your class marks, and this will be starting right from your roll number 1 up to your roll number 53. Okay, 1 to 53, and you can see how it is sort of varying. And wherever you see this marks which is sort of coming down, there are 4 points which are sort of coming down a lot. Okay, 4 people who have scored very less marks, people who have failed, 4 people who have failed. You can see the points that are coming down right here. 1, 2, 3, and 4. 4 marks, 4 people where the graph suddenly comes down. Okay, but so suddenly it sort of comes down. Okay, if you take this, okay, if you take this and maybe plot it for, I don't know, probably for a area graph. Where's area graph? Yeah. A area graph like this, where do you think the majority of it is coming through? Or else I'll go for a line graph itself. Okay, where is the majority of the people coming through? The majority of the people are basically in between your 50 and probably very less people touching 80, so 70. Okay, so if you take that into perspective, maybe 60 to 70 is a marks where majority of it is getting satisfied. Okay, 60 to 70 is the points. Between 60 to 70 is the point, data points, where majority of it is getting satisfied. Okay, as you can see very clearly, and because the average is 66. Okay, so you can easily make out from even from the visualization tool, which is a graph that here, and of course from the numerical value, which is nothing but finding out the average just like that. Okay, even from the tool, it becomes very important, very easy that the majority of it is getting satisfied between 60 and 70, even though the average being your 66. And there are certain points who are outliers. You can see who are the outliers, the ones who see here. You see on tops, you see the ones people who are coming right here. Okay, there's one person who's got 91 out of 100. And there's one person who's got close to around 89 out of 100. 2 outliers here. And there are 4 outliers here who have got very less marks. Okay, whose marks is close to around 40 out of 100. I'm talking. Okay, so these are known as outliers. The people who are not going to come in a particular line. If I make a sort of a line here, okay, if I sort of plot a line like this, what is going to happen here? Okay, the line will probably work in a way that majority of it is getting satisfied between 60 and 70. I can make out a date from this. I can make out from a what do you call the entire impact can be sort of known from this, and you can see even from a scattered graph. Okay, the ones what you see right here, the majority of it are getting satisfied between your 60s and 70s. and the one which you see right here, the outliers, are the ones which are not really coming into the group. Okay, it's a graph that probably is not worthy enough. Should have been more than that. Okay, I don't know, again, you people taking the online thing seriously and then going offline and thinking offline exams will not be there. This is going to happen. Okay, this is bound to happen. That should not happen. Okay, so yeah, so let's come back. Okay, let's come back. See, like that you can make out various data. You can take out various data for yourself. Okay, you can take various data so like that for yourself, and you can sort of figure out where do you think and what do you think is the advantage of having a data and then having a very good visualization tools. Okay, just by looking at it, people should be able to understand. That's very important. Okay, so let's look into the next aspect of it. Okay, in our yesterday's class we were talking about data mining tasks. In data mining tasks we were talking about prediction and description. Okay, two tasks. And in prediction, what are the tasks that you have? In description, what are the tasks you have? And now today's example, we are going to look into what is known as classification. Okay, what is known as classification? Now you can see the example that you can sort of look here. There is a table that is given with IDs, with employed, whether he is employed or not, yes or no values. So two values there. And what is level of education based on year of stay, and whether it is a credit, is worthy of taking a credit card or not. Based on that, you can see very clearly how the data is going to. This is the training set. And then we are putting into a classifier. You are going to classify that data into some sort of a thing. Okay, now see the first one. It's very much categorical. What is the thing that says the level of answers for it will be very, very easy. Yes or no. Graduate or high school. Graduate or undergraduate. Only two values here. Only three values here. Here, the value will be quantitative. Okay, it can vary from 1 to 10. And here again is with regard to two values only, right? Whether it's worthy or not. Based on that, I put the data right here. Okay, put that data right here, and you can see the entire thing of how it is getting modeled and all. Okay, how it is getting modeled and all. You can see from this example also, and from these examples also, you can sort of make out what is the way this entire classification thing works. Okay, and where do you think this classification examples come through? Okay, the one which you saw. How you can classify whether a person is worthy to take a credit card or a debit card or not. Okay, whether it can be a legitimate one or a fraudulent one. Then what's the other one? Classifying the land covers. How do you classify a land cover? Whether a particular land cover is a water body or an urban area, or whether it's a forest, using what? Your satellite data. That's what we do, right? We use your Google map just to figure out what sort of an area it is. There's too much of the forest cover. It predominantly comes from or predominantly rural areas. It predominantly it will never be an urban area. Okay, if there's a lot of lake or a water body that's coming through, then you call it as a water body. Okay, like that classification tools can be used to do all these things. Okay, one is classifying the credit card transactions, classifying the land covers, then categorizing the news stories as what? Finance, weather, entertainment, sports. That's what even the newspapers do, right? They classify the entire data based on the headings of our pages. Okay, identify the intruders in the cyberspace. What type of an intruders they are. Probably all these things you would have learned it maybe in your 4th and 5th semester when you studied maybe your DC, CNS, all those things. What types of intruders that you have? Okay, types of attacks, types of intruders. Okay, then predicting tumor cells in benign or malignant. Okay, what is the things with regard to this? There are tumor cells which can be removed, which cannot be removed. The tumor cells which are very harmful and which are not. Okay, classifying the secondary structures of protein as this probably will be able to understand because it's predominantly biological terms. Okay, write it or you can just leave it. Okay, as an example, what is it? Classifying an entire protein structure, which is nothing but an RNA structures that you have in your, the rhizobium, all those things. Remember that, okay? RNA, DNA structures and all, okay? That as what? Alpha helix, beta sheet, or random coil. to too much biological terms there. Probably you can sort of understand right from your Google thing itself. Okay. Now, what is, we move into what is known as a deeper insight of what are the applications of your classification. Okay, deeper insight. So first one, we take it as fraud detection. What is the thing that we can be doing here? We are going to predict whether a particular card, okay, whatever the credit card transaction that happens is fraudulent or not. So what is the approach? Approach is very simple. We take the credit card transactions and the information of the account holder. Okay. Then what does it do? Then we figure out the very simple things are when does the customer is going to buy? What is he buying? How he always pays? Okay, how he pays generally. Then we are going to label the entire past transactions based on it as fraud or fake transactions. Okay. See, we are having data. We are having data. Based on certain data, we are predicting something. What is the data we are already having? The data we are having is his past transactions. What is you are trying to predict? We are trying to predict some things which is whether he is going to do the fraud or not. We are going to learn a model for the class of transactions. Okay. Then we are going to use this model to detect the fraud by observing the credit card transactions on the account. So only you have a dependent variable here and also an independent variable here. Or we are going to take up, we are going to keep on data, and based on that data, we are going to predict one more data. Okay. Example for fraud detection, an example under classification. Okay. Very important for you to get to know it. Then the next one, application 2. What's the next application? To churn prediction for telephone customers. Probably a application which people in marketing people will do. So what they do to predict whether a customer is likely to be lost to a competitor. Okay, people who want to switch, okay, want to switch from one telephone operator to one more telephone operator. I think probably these people would have got to know that. Okay, so what they do, they use the detailed record of transaction with each of the past and the present customer to find the attributes. So what are those attributes? How often the customer will call, where he calls basically, what time he calls, his financial status, his marital status, everything. Okay, everything can be found out based on your call transactions. Then you figure out whether a particular customer is very much loyal or not. Okay, is very loyal or not. Then you find a model for his loyalty. Okay, then you send a message for switching from one telephone operator to one more, be from Airtel to Jio. Suddenly there'll be a callback from the Airtel guys asking why you are doing this. Then you will say you complain, okay, that you are not getting a proper offer, you are not getting proper signals, something like that. Then what they do, they'll not say, okay, no, fine, you switch. They'll not say like that. They will come up with a solution of, okay, we are going to provide this, we are going to do this, we are going to do this, because no one wants to lose a customer. Every customer counts, right? Every customer counts, every operator counts. Okay, so what they do is they'll be providing you with some sort of a solution for it. Even after that, if you are able to do, then probably they'll not be able to do anything, right? But there will be a backup. They will be having a backup of doing something related to it. Okay, so that's what we do. Okay, churn prediction with regard to your telephone customers. Okay, then you take one more example. Okay, Sky catalog. Probably this is something again which which I like, because too much people who like physics a lot. Okay, learn about science a lot. When I say science, not computer science, the real science. Okay, the science of everything. The very good shows, Nat Geo's Discoveries, right, which talks about science of everything. So everything that happens in the world has a science behind it. Okay, even the very minute things that happen, or a very major incident that happen around the world, has science behind it of why it is happening. Okay, that's called science of everything. Okay, very good shows, you could always watch. Okay, so what is this example? The Sky Survey cataloging. So what does it do? You are going to predict whether a star or a galaxy of star objects, especially visually faint ones, What is this? You are going to take 3000 images with to think about the pixel range here. Okay, we always think of 1080 and we say it's a HD. Okay, too much HD. Even 720 pixels we take it as HDs. So, but here I'm talking about 23040 pixels per image. Okay, we segment that image as what? Measuring the image attributes as 40 of them per image. And what you would do? You are going to figure out whether that entire thing, okay, that entire thing are basically like this. Okay, this again, it's a physics example. Even if you don't understand, there's no need. Okay, see, you just have to write what is classification, examples of classification or applications of classification. That's all. All this thing is for your extra information. Okay, understanding things. That's all. Because I don't want to make it even more boring with regard to data mining. What is this and all? Just figuring out. It's like understanding extra things. If you see a pictorial representation, probably you'll understand. Okay, probably you'll be remembering that. Okay, this is what it is. Okay, now you can see the classifying galaxies. Okay, we have something called early galaxies, intermediate galaxies, and late galaxies. And you figure out what you call the images of it, and all these images are basically taken from very powerful telescopes, right? So you can see this. Okay, data size, what it is: 72 billion stars, 20 million galaxies, object catalog, say 9 GB image database. You don't have to know this. You can figure out that a particular galaxy can be classified as early, intermediate, and late. Okay, and what is the classification thing? The stages of formation. What are the attributes based on which it is done? It is done based on the image features. Okay, characteristics of your light waves, etc. Okay, so light waves is not a measure of light; it's a measure of distance. Okay, probably you would have known that. Okay, light waves, it's not a measure of how much light it is. It's a measure of what is the distance. Okay, so that's with regard to classification and all. Then you move into what is known as regression. What is regression? It's again a data mining technique. Okay, doing what? To predict a range of numerical values. To predict a range of what? Numerical values. How? Based on a particular data set. Okay, to predict a value of given continuous value variable based on a value of other variables. That's what we call it. Even in the previous examples which you have seen. Okay, that it is whether it's a linear or a non-linear model of dependencies. Okay, example is a regression might be used to predict what cost of a product or a service given other variables. What is that? Okay, think about your area. Okay, your own area where you are staying. I want to predict what is the cost of your house 10 years down the line. 10 years down the line, what is the cost of your house? How it can be done? Predicting that is my thing to be kept in mind. What are the variables that will sort of support that? Whether your area has proper roads in the next 10 years, all the other facilities, the malls, the shopping malls, the parks, okay, the entertainment centers, anything and everything live into a living condition. Everything that is going to come in the next 10 years. Will it be available or will not be available? That one. And what is the present status now? Based on all these attributes, we can sort of figure out what is the cost of your house in the next 10 years. Okay, that's called prediction. That's called prediction. And remember this, why I gave this example. This will be one of our project which you people will try to do in machine learning in 7th sem. You are going to use the data set, okay, of maybe hundreds of houses and their costs in the last 10 years. And then you are trying to predict what will be the cost in the next 1 year, 2 years. This will be a very simplistic of project. Okay, which will be very simplistic of project, which probably your seniors also would have done it. Okay, so you're not going to do it. Okay, people will say rejected. Okay, but that you can take as an example to explain this. So regression analysis explains the changes in criterion in relation to changes in the select predictors. Okay, what is that basically? It is based on the predictors where the average value of a dependent variable is given when the independent variables are changed. Okay, where do you think it can be used? It can be used in your business and market planning, financial forecasting, environmental modeling, analysis of trends. Everywhere you can use this regression analysis. Okay, what are three major regression analysis that you can have? First one is with regard to strength of predictors, forecasting and effect. That's what I told you just now. Trend forecasting, which I again told you. Okay, forecasting and effect for trend forecasting. All those things can be taken as an example for your finding out the cost of your house in the next 10 years. Okay, all these things comes under a thing called regression. Regression is a very huge topic. There are various types of regression analysis. The simplest thing being your linear regression. Okay, you're going to learn a lot about it again in 7th sem. Here, only things that are needed I've put, a little bit extra only I've put. So you just have an idea before we move into the 7th sem. Okay, so what are the examples that you have? Predicting the sales amounts of a new product based on advertising expenditure. Okay, so that's one of a model that you can do. I have spent 1 crore rupees on advertising. What may be my sales from a particular product? I'm selling a toothpaste, and I've spent 1 crore rupees on advertising. So that ads would have been seen by at least 1 crore people. Okay, 1 crore people. In that, maybe 50% of them are interested. In that 50%, around 50% will be going to a shop to even inquire about that. Okay, in that again 15% will be taking that my toothpaste costs 40 rupees. Okay, so what is the the amount of thing in 1 crore people? 50% went, so 50 lakhs. In that 50 lakhs, other 50%, 25 lakhs. In that 25 lakhs, only 12 lakh people only got my toothpaste. Okay, my toothpaste costs say 50 rupees. 12 lakh people into 50 lakh, 50 rupees. That will be giving you what will be my sales expenditure, or what will be my sales prediction. Okay, predicting the wind velocities as a function of temperature, humidity, air pressure, etc. This is what everyone does in when it comes to weather forecasting. They'll take few models, few attributes. Based on that, they're going to predict something that is going to happen. They generally take the temperature. Generally, they're going to take the wind velocities, where the wind is blowing. Okay, then they take what is known as humidity. Okay, when you go and watch any weather forecasting related topics, right? These things will always be there. Temperature will be there. Wind velocity will be there. Humidity will be there. Based on these things, they'll tell what is going to happen in the next 1 day, 2 days or in that particular day, whether it's going to rain or not. Okay, rain is generally depend on these three factors. Of course, there are many other factors that it may depend, but generally depend on three factors, which is based on temperature, wind velocity, and of course humidity. Humidity ka matlab, it means what is humidity? It is amount of dampness or water vapors or water bubbles that are present in the atmosphere. Okay, these are the things that people think of. Okay, then what's the next thing? Time series prediction of stock market indices. This is something which is a huge, having huge potential, but none of you will be able to do it. Not just you people, even the biggest of biggest stockbrokers can never predict how the stock movement will happen or how the market movement can happen. That's why stock market still runs. If people would have been able to sort of predict, okay, how the stock market can really go or how the stock market will be able to move and all, only those people would have become very, very, rich. Other people would have lost all the money. Okay, there's few things which people can never control: the environment, the stock market, okay, Some people may be thinking I can control stock market like an Arshad Mehta, seeing all that the series, right? The very famous series. You would have seen it as a time, the television series, and would have think, maybe I can control stock market like him. No, even he was not able to do it. No one can control stock market. If they control, they do it for maybe a very little span of time. Okay, but it's a very interesting aspect that people can always look for. Okay, time series prediction of stock market indices. I don't know, I mean, if you are sort of knowing about stock market and all, if you sort of people, especially from people from the western part of the country, Gujarat, Rajasthan, people from there, probably they'll be knowing a lot. Okay, so all these things are examples for what? These are examples related to figuring out how regression analysis can be put into perspective. Okay, so next thing is we move into what is known as clustering.